Hey, this is chapter 13.6, and we're going to be covering the law of cosines. So with our law of sines, we've already solved for triangles in which we have our angle, side, our angle, side, angle, and side, side, angle. So these are triangles in which these are our given values. So for example, if we know two angles and a side, or an angle, a side, and then another angle, we know what to do when we have that information. But now we're going to be using the law of cosines for cases of side, angle, side, or side, side, side. So if we want to find the side length of A, for example, A squared equals B squared plus C squared minus 2B cosine A. And this may seem like a lot to remember, but just imagine if you're solving for A, you place the other two variables, B and C, square those and add them together, and then you subtract 2 times BC, so this actually should be C here as well, BC cosine A. So you take the BC and you add them squared, and then you multiply them by 2, subtract that, times the cosine of the angle of the side you're trying to find. So therefore each of these would be the square root for simply A, because this is A squared. So we're told to solve the triangle ABC with the side A being 11, the side C is 14, and our angle B has 34 degrees. So our first step is to draw this triangle. So we have one line here, or one leg, second leg, and a third leg. So we have our triangle, and we should label our A, B, and C. So A, B, C, in which B is 34 degrees, A is 11, and C is 14. So our second step is to find side B. We're going to do this by using our law of sines. So for B squared, we had B squared equals A squared plus C squared minus 2AC times the cosine of B. So we plug in values for A and C, so 11 squared plus 14 squared minus 2 times 11 times 14 times cosine of 34. And for this, we get B squared equals 61.7. So this is simply 61.7, and then we square it to get B equals 61, root 61.7, which is approximately 7.85. So that we've solved the previous problem with side, angle, side, and now we have side, side, side. So we're solving triangle ABC once again, except this time A is 1, B is 27, and C is 20. This should actually be 12, not 1. So A is 12, B 27, and C is 20. So we have the same steps. First, we're going to draw our triangle. So we've drawn our triangle and labeled our given values. So next we're going to be solving with the law of cosines, even though we know all three sides. We're going to be plugging in our values for those sides and solving for an angle measure. So we can use the same formula of B squared equals A squared plus C squared minus 2AC cosine B. So plugging in our values, we can solve for the angle B. So we're going to put everything else on one side. So we have 27 squared minus 12 squared minus 20 squared over negative 2 times 12 times 20. This should actually be times 12 equal to cosine B. Next, we can plug this into our calculator and we get negative 0.3854 is approximately cosine B. Then we will take the negative cosine to find simply B. So it's not really called the negative cosine, it's the inverse cosine. So take it of this, This gives us 112.7 as our angle measure. Now we're going to use the law of cosines to find A. So we're going to set this up with sine A, sine of angle A, over side A equals sine of angle B over side B. This is our law of sines. And then we're going to plug in our values. Once again, we're going to be solving for our single variable, so we need to have sine of A by itself. So we have sine A, again our capital A is our angle, sine A equals 12 times sine 112.7 degrees over 27. So we've multiplied both sides by 12. This will cancel at 12 and leave our sine A by itself. This simplifies to 0.4100. Take the inverse sine of that to find A. And A is 24.2 degrees. Now we have A and B, and to find C we simply subtract both of those values from 180. So C equals 180 degrees minus 24.2 degrees minus 112.7 degrees equals 43.1 degrees. So now that we know our angles of A, B, and C. So in this section we also have Heron's area formula, which is the square root of S times the quantity S minus A times the quantity S minus B and times the quantity S minus C, where S is 1/2 times A plus B plus C. So this is when we're finding the area of a triangle and we're given all three side lengths. So we're given, let's say, 12, 9, and 3. This is not a scale, of course. And so we know that these in turn will be A, B, and C. So let's find the area of this triangle. First, we need to find S, which is going to be 1/2 times A plus B plus C. So we have 1/2 times 8 plus 11 plus 5. So S equals 12. Now we're going to plug this into Heron's formula, which is the square root of S times S minus A times S minus B times S minus C. So we can plug all of our values into this. We get A equals the square root of 12 times 12 minus 8, 12 minus 11, and finally 12 minus 5. So we simplify this and we get 336 is our area. So we can say units squared because we're not given units.